Hey guys, here's what you need to know, the rest that you need to know for Unit 1, and also a review for Unit 1 test. Here we go. First thing is domain and range. Of functions. The domain is on the x-axis. It's your x. It's your input. It is your independent variable. So here's your graph. Here's your x-axis. That is the domain. The range is, of course, the y. It is the output. It is your dependent variable. It can be found on the y-axis. Okay? So we have domain, we have range. We'll talk about more of those in a second. The next two vocabulary words are continuous, which means a line, a solid line. Example would be this. It's continuous. It might have specific points, which we'll go into later, like 36 is less than or equal to x, which is less than or equal to 52. It's just an example right there. The next vocabulary is discrete. Those equal exact points. Here's an example on the graph. And that would be when they put exact points. So what they're looking for is the exact points on the graph. So they would list them like the exact numbers. So we know continuous is a line, discrete is points. Next, we're going to talk about linear, domain and range. We learned up here, domain is the x, range is the y. Let's draw an example. We know domain is the x. And in this example, since this keeps going on forever, the domain would equal all real numbers starting from 0. Because this is 0 and it includes all the numbers going that way. The range of this graph, the y, would equal all real numbers also starting from 0. All those numbers. There's your x-axis and your y-axis. So we know domain is the x, the range is the y. They want us to explain more about the y-intercept. The y-intercept is the starting point of an equation. So we know y equals mx plus b is our equation. And we know it would cross the y-axis. It would start on the y-axis. Let's say you started with $100 and you spend so much each week that at the end of however many weeks there are, you have $20 left. So we know you start with $100 and you keep spending and when there's 0 weeks left, you have $20. So this is your money. This is your weeks. Starting point. The y-intercept is the starting point. Okay, next page. Here's some more stuff. So this is page 2. Another y-intercept example. So let's say you have tickets and you have carnival tickets and carnival rides. Let's say you start with 40 tickets. So what this is telling us, that your starting point, you start with 40 tickets. And as you spend the tickets, you ride the rides. And when you get to the end and you have 0 tickets, that means you rode 80 rides. That's what it's telling you. Okay? Next thing is quadratic domain and range. For this test and this part of quadratic domain and range, the domain, which is the x-axis, is going to be all real numbers. Okay? Forgot to highlight this. The range will be your y-axis, and that's going to equal the minimum or the maximum that we've already been doing in class. And I'll show you how that's going to look here. First, let's do the domain. Here's two graphs, that could be it. Here's your x. There's your parabola. It could also be going down. Okay? The reason it is all real numbers on the x-axis is because as this keeps going, it's going to keep going out. The parabola is going to continue opening up. Therefore, it's going to include all the numbers on the x-axis, because the x-axis keeps going out this way. The parabola opens up this way. So this is domain examples of all real numbers. Okay? Let's do a range examples. Okay, so here's a graph. And let's say the parabola is up like this, and then it goes back down. So we know the range is the y-axis. And we know since this is opening down, because we already did this, it's going to have a maximum. And let's say this number here is 5. So we know the parabola's maximum is 5. And it includes 5 and all the numbers going down forever. So the way they would write that is y is less than or equal to 5, because this is less than. So y includes all 5 and all numbers smaller than 5. Another example, let's do one going up. So this is our max of 5. So let's do one opening up. Let's say it goes like that. And let's say right here is -2. So since it's opening up, it has a minimum of -2. So therefore the range would include -2 and all the numbers bigger than -2. So y includes -2 and all numbers bigger than -2. They would write it like this: y is greater than or equal to -2. Okay? And remember, we already learned this. If it's opening down, it has a maximum. And if it's opening up, it has a minimum. Okay? Last part. We've already learned this part in class, and we want to remember. That quadratics, whoops, there you go. Remember, quadratics with a positive a have an absolute minimum. They have a minimum. Okay, here's the example. F of x equals 2, there's a right there, x squared plus 4x minus 6. So we know they have a minimum, and it's going to be opening up. Okay? So therefore, if a is a negative, it will have an absolute maximum. Okay? So here's an example. F of x equals negative 3x squared plus 5x minus 2. There's your a right there. And we know it will open down. We learned this yesterday. Functions. Is it a function? And here's an example. Here's a table. So we have our x and our y, and our x is 0, 1, and 2. Our y is 4 and 4 and 4. 0, 1, and 2 do not repeat, so it is a function. Now, this part, they seem to want exponential functions shown, and I think we did some of them. They could look perhaps like this. This is an example of an exponential function. And it might also go down, but right now I just drew it up. This is always a function. Exponential functions are always a function. Yes, always. And the characteristics are, they could be, like we learned on the previous page, they could look like they are continuous. And in this case, this one is increasing. And this one is decreasing. This next one would be discrete and decreasing. And finally, I kind of did it here, but I'll just do it one more time here. We have continuous, increasing, and this should curve out a little bit more. And then we have discrete, increasing. So this is it. This is the new stuff that we haven't covered, plus some of the stuff we have covered, and it is going to be on the test. Positive A has a minimum. If A is negative, it has a maximum. Here's A. Is this a function? The x doesn't repeat. Exponential functions are always functions. Yes, always. And here's how they would look if they're continuous decreasing, discrete decreasing, continuous increasing, and discrete increasing. That is it, guys. We will finish up our review and recap tomorrow and Tuesday, and the test will be on Wednesday. Thank you for watching.